Hello, today we are going to look at sketching graphs or sketching functions. So sketching and plotting are slightly different things. We've done a lot of plotting of functions in the past where we would have gotten a series of points, usually 1x apart. So we would have, say, had a domain that would have gone from x is -2 up to x is 3, and we'd have found out what the value of y was for all of our x values. We'd then have a series of points and we plot them on the curve and maybe join in the dots. So that's graphing or plotting. Sketching is a little bit different. It's a less accurate way of doing things, but it's much, much faster. And its general purpose is to give a feel for what the function is doing. It helps build intuition, and for developing skills at higher level Leaving Cert, it's a very important skill to constantly be reinforcing. So anytime we can draw a very quick sketch of our functions, we should always do it so that we have the shape of the functions, how they behave in different areas, really sorted in our minds for when we're trying to do work. Because a lot of the challenge of higher level Leaving Cert is being able to interpret the questions and understand what we've been asked. And sketching graphs of functions can be a big, important component in doing that. So, in general, we're going to know the general shape of a function, and then we are going to take a few key points and we are going to use the knowledge of the general shape and those points to get a rough idea of what the function should be doing. In the case of linear functions, that is to say functions with the highest power of x is 1, all we are going to need to do is get the x and y intercept. Now there is another way of doing it, which is to say if we have it in the form y equals mx plus c like we have here, so this is an important version of the line equation, y equals mx plus c, which I may as well write in, y equals mx plus c. The c on the end, the constant on the end, always tells us the y-intercept without having to do any work. I know automatically if it's written in this form, y equals stuff, the constant on the end tells me the y-intercept, where I cross the y-axis. Why? Because everything else involves an x, and when we're on the y-axis, x is 0. So to find the y-intercept of any function, it doesn't matter if it's linear, quadratic, cubic, quartic, doesn't matter. If we have a constant on the end when we have y equals everything, then we know the y-intercept automatically. We also know in the form y equals mx plus c that the number in front of the x, the coefficient of the x, is the slope. So another way of solving this problem would be to say, well, if I go across by 1, I go up by 2. But in general, the fastest way to do this is going to be, or in general, we can use the x and y intercept. So this is a good way of reinforcing what happens on the x and y axis. So when x is 0, that's us on the y-axis. So we're going to find the y-intercept. So on the y-axis, x is 0. So we set x equal to 0. And we have y is equal to 2 on 0 minus 1 is equal to minus 1. Then I'll write down the coordinates of that point to reinforce what I'm on about. X before y, just like it is in the alphabet. So 0 minus 1 is a point on my line. And I can mark that in. 0 minus 1 would be this point in here. And I can mark that on my graph. And on the x-axis, which we would also call a root, it's important to reinforce our language, y is going to be equal to 0. So we're along this line where y is equal to 0. So we set y equal to 0. This is our function up here again. 2x minus 1. Rearranging that, we will end up with x is equal to a half. You can write a 0.5 if you're more comfortable with that. So we have a half. 0 is the root of our function. And again, marking that in. We would have a half here and minus 1. Now with a straight line function, with a linear function, at this point we've got everything we could possibly need, because all we have to do now is take our ruler and we're going to draw in a straight line using our ruler, because it's not going to vary from these 2 points. So our sketch just requires 2 points for a linear function, and then we just use our ruler to go straight through those 2 points. So we draw in our straight line with our ruler, and just to reinforce again, the other version of this would be to say, well, I know the y-intercept is -1, and I know the slope is 2, so 2 over 1. If I go across by 1, I rise by 2. So if I go across by 1, I rise by 2. So I know the point 1, 1 is on the line, and then I could use those 2 points to draw a straight line through. Both of them are valuable ways of being able to look at linear functions, and there is no problem knowing both. So that is the general outlook on our linear functions. Quadratics now. For quadratics, we're going to get our x and y intercepts. Our x-axis intercept again is called the roots. The y-intercept we know is when x is 0, and the max or the min is going to be the top or the bottom of our curve. Now, a quadratic, a positive quadratic, is going to be a smiley face, positive for a smile, and a frown for a negative quadratic. So the coefficient in front of this squared term being positive or negative tells us whether we're dealing with a smile or a frown. And that is what we need for the general shape of a quadratic. And what we're going to do is get a few points that are going to allow us to effectively hang that shape in a particular orientation. So let's have a look at y is equal to 2x squared minus 4x minus 6. How are we going to get our points to allow us to sketch this curve? So not graph or plot, we're not going to just get a series of points, we're going to get some key points. And we're going to start off by getting our roots, which we're very familiar with doing. So this is just a quadratic. If we're looking for the roots of it, we could use the minus b formula in our log tables. But for right now, we're going to practice the more important skill of, or the generally more important skill of, factorizing. So we can go through our different processes for figuring out our factors, but when we go through our normal factorizing steps, we will figure out that we need -2, 6 and +1. So we will factorize into 2 brackets, and then either of the brackets individually could be equal to 0. When we rearrange this, we will get x is equal to 3 and x is equal to -1. Now this is not enough information to really accurately draw our curve. We need at least another point. We'd need at least the y-intercept or max and min, and in practice we're going to always get both so that we're covering all our bases. So we are next going to get our y-intercept, which we can read directly off of this, but just to reinforce it, the y-intercept, so y-axis, x is going to be equal to 0. I know I can just read off that it's going to be -6. I'm deliberately reinforcing what I need. And there's no problem in an exam with you just reading off that that would be -6. No issue at all. But we're going to reinforce that we know that on the y-axis, x is 0, because it's a key part of lots of different parts of our course when we're trying to interpret things. So y is equal to -6. So I know that 0 minus 6 is on my curve. I know that 3, 0 is on my curve. I know that -1, 0 is on my curve. Well, now I'm going to get my maximum and minimum point. And how am I going to do that? Well, in the long run, max and min are going to come from differentiation. So max and min is going to come from dy dx. You do not know what this means right now, but you will later. Dy dx equals 0. So you can keep that in as a little note to yourself. This is the more important way of doing it in the long run, but we must know completing the square. They can explicitly ask us to complete the square in the exams. But in the long run, you will use something called differentiation, and you're going to find where the slope of the tangent to the curve is equal to 0. Doesn't mean much now, it will later. What we're going to do now is completing the square, and I'll do a brief reminder as to how we complete the square in order to find the max and min. When we are finding the max or min point, in this case we know we are going to get a minimum because I know the general shape of this curve is a positive quadratic, so it's a smiley face, so it has a lowest point, a minimum point. But how you find it is take out the factor that is in front of the x squared. No matter how awkward it makes your numbers, always take out the factor that is in front of the x squared. In this case, it doesn't make too awful a job. It's still reasonably nice whole numbers. Then we're going to add and subtract half of the number in front of the x, half the coefficient of the x. So minus 2 all over 2. We're going to add and subtract plus and minus. So that's going to be minus 1 to be squared. So adding and subtracting that, we get 2 on x squared minus 2x plus minus 1 to be squared minus minus 1 to be squared minus 3. And that's all still multiplied by 2. And y is equal, this is now in the form of a perfect square, which is what we were aiming for. So we get 2 on x minus 1 to be squared minus 4, that's still all multiplied by 2. Y is equal to 2 on x minus 1 to be squared minus 8. I'm going to need to slightly rearrange my page here. Now, what this tells me is that this function is going to have its minimum when our squared bit is equal to 0, because the smallest value that can come out of our quadratic piece, the bit that's squared, is 0. Anything that is squared, any real number squared, is either 0 or greater. If we square a negative number, we get a positive number. So the smallest thing we can get out of here is 0. So to find the minimum, we are going to figure out when x minus 1 is equal to 0. Well, that's just going to happen at x is equal to 1. And when this is 0, y is just going to be minus 8. This bit is 0 at the minimum, and then we are going to have y equals minus 8. So therefore, the minimum happens at x is 1, y is minus 8. So that's our completing the square. And we now have all of our different points that we need for drawing in our curve. So let's mark them in. We have our roots are at 3, 0 and minus 1, 0. Our y-intercept is at 0, minus 6. I've written in my axes wrong there. I need to rewrite them. Apologies. So we have our y-axis is going down in 2s to make it neater on the page. You can do it in units if you like, if you have space. And then we have our minimum. The lowest point of our smiley face is going to be at 1 minus 8. And then we are going to go in and freehand draw in our quadratic curve. Do not use a ruler for this. They will dock you a massive amount of marks if you use a ruler to try and draw this. Okay, that's not too bad. So this nice rounded type curve, there are no straight lines going on here, and it's important we demonstrate that. Final reminder, if we were given information the other way around, if we were, say, given this curve and we could figure out the roots were 3 and minus 1, and we had a point on the curve was 0, minus 6, we would say that the function was equal to k times our factors multiplied together. So if we have roots, we can produce our factors by rearranging to make them equal 0. And we'd have x minus 3 on x plus 1. And then we would use our point to find the missing k